We're starting section 3.2 today on the derivative as a function. And what you're seeing here is the first Geogebra applet that I have posted in our Moodle resources for the week. So if you want to play along with it, you can. So what this function that is graphed here with all these little horizontal lines on them is going to do is help us to graph the derivative of this function, f prime of x. So remember what the derivative tells us. It tells us the slope of a tangent line at any given point. So what we're going to do, you can see each one of these orange or green circles has a white circle below it, and the white circles are draggable. So we're going to drag those white circles to a y coordinate that matches the slope of the tangent line. So let me show you what I mean. On the left-hand side, the first orange point on the left, I'm going to grab the white dot below it. And that tangent line is going to have a negative slope to it. So I'm going to pull this white dot below it down to a negative y coordinate. And I'm going to keep pulling it more and more negative until that line looks like a tangent line. And we're going to do this with all the points that are labeled on this graph, on this f of x. So I'm going to grab this point for the green one and keep sliding it negative until that negative slope looks like it matches the tangent line. This third point here, it looks like the tangent line might actually be in the right spot, horizontal. So the white dot, the y coordinate of the derivative, is equal to 0, a 0 horizontal slope. Okay, moving on beyond that point, I have a green point. Now this one's going to have a positive tangent slope. So I'm going to pull that up to a positive y coordinate until I get the right slope. And notice that the steeper the tangent line is, the higher the slope is. That's what we know about lines. And so we get a little bit higher on that one. And then the slopes are going to start to decrease, still positive, but going back down. And then once we get over that hump on the right-hand side of the graph, the slopes are going to turn negative again. So my y coordinates of the derivative are going to turn negative again. So I'm going to pull this one down negative till it looks like it's tangent. And then that's bigger negative because the tangent line is steeper there. And then the last one is going to have the biggest negative slope on the right-hand side here. All right, so those white dots down below should be points that are on the derivative of f of x. It's going to be approximate because I've been eyeballing these tangent lines, but you can click the button that says check your work, and it's going to draw in the actual graph of the derivative. And it looks like our points are pretty close. Here we have the second Geogebra applet that I have posted in the resources for the week again. And this one you can type in any function that you want to, and it gives you a white draggable point with the tangent line there drawn. And what it's going to do below is to graph the y coordinate of the slope of the line that you're on. So I'm going to grab this white dot and kind of trace it along the function. And right about here, I get to a point where the y coordinate is -1. And that means that that tangent line at that specific spot has a slope of -1. So again, this is just drawing the derivative based upon the slope of the tangent line at each point. And this one, for some reason, changes color when you're at a negative slope. And then when you hit 0, it turns white. And then once you're in a region with positive slopes, it turns green. So Christmassy derivative graphing applet. All right, it's a little late for that. All right, so then you can actually say show derivative function. It'll actually graph the correct function for you. And again, you can type in any function into this applet up in the box at the top, and it will show you what the function is and what the derivative is, and you can kind of drag along and graph the derivative with that point. Now for the hard part. We are going to be the applet and try to draw the graph of the derivative given the graph of the function. And when a human being is doing this, the easiest place to start are at places where the original function has a horizontal tangent line. So I've got 3 of those in this graph. The first one that I see is over here at -3. So at that point, if I draw in the tangent line, it looks like it's completely horizontal. A horizontal line has a 0 slope, so that means the derivative is going to have a 0 y coordinate there. So right below that horizontal tangent line point at -3, I'm going to draw the derivative having an x-intercept. That's a y coordinate of 0. All right, so any place the original function has a horizontal tangent, the derivative is going to cross the x-axis, have a y coordinate of 0. So that happens again here on the y-axis. I'm going to go down below that and give myself a x-intercept, and then again at x equals 4. I can see I've got a horizontal tangent line, so I'm going to have an x-intercept there. All right, so let's think about the left-hand side of the graph. So we're going to build this left to right. So over here, to the left of that first horizontal tangent point, you can kind of mentally draw some tangent lines and realize that they all have negative slope. We're falling left to right. We're at a decreasing portion of the function. So we're going to have negative y coordinates for the derivative. And I'm just going to try to figure out one negative y coordinate to kind of give me a landmark on the graph. So I'm going to pick a point. Let's pick at -4. Let me clean my graph off here. So at -4, I'm up here, and I'm going to take a ruler and draw myself a tangent line. And we're going to try to figure out what the slope of this tangent line is. And this is all approximate. So once you have that line drawn, you can pick any 2 points and kind of calculate what the slope of that line is. It's definitely negative. All right, so I'm going to pick a 1 tick mark horizontal spot on this line. So let's see, I could go from where we're at -3 to -4. And just kind of estimate what that slope is. So I've gone a little bit more than a tick mark, so 1 point something. So I'm going to plot a point for my derivative at -1 point something. And again, I'm just measuring that this is a run of 1 and that this rise is a negative, I don't know, say 1.2. And again, we're just approximating. Okay, so at -4, which is where I drew the tangent line, I'm going to go down and plot myself a y coordinate of like -1.2. So that's my best guess of where the derivative is going to be at that point. All right, so let's do that for each segment of this graph. Just plot 1 tangent line and try to get a good point for it. All right, so something in between those 2 x-intercepts at -3 and 0, I'm going to pick -2. All right, and I'm going to use my ruler, draw a tangent line, and see if we can estimate its slope. Okay, so this one's going to have a positive slope. And again, just pick a 1 tick mark x region so we can count what the rise of this line is. So if I go from -2 to -1 and then make it back up to the line, okay, that is a positive slope. So I've got a run of 1 and less than 1 for the y rise of that line. So I'm going to say, let's say 0.75. And again, we're just estimating, so it's not important that you get it exactly right. You just want a kind of landmark of where we're at. All right, so at -2, which is where I drew the tangent line, right below that, I'm going to give myself a positive 0.75 slope. All right, let's do 2 more. I'm going to do 1 point in between 0 and 4. 2 seems like the natural choice. So I'm going to come over to 2 and use my ruler to draw myself a tangent line. And then we'll try to estimate the slope of that line. Okay, so from 2 to where we're at 3. So that was a run of 1. We're back to negative slopes here. So how much have we gone? It's another one that's like 1 and a bit. So we'll do another -1.2. So I'm going to give myself another y coordinate of negative something, 1 point something. All right, and then I'm going to pick one more spot, something that's past x equals 4. So x equals 5 seems like a good choice. And we'll come in here. We're back to positive slopes for a tangent line. So we're going to be above the y-axis. We just want to figure out how far above. So draw yourself something that looks tangent-ish, and then try to calculate this slope. So I'm going to go 1 tick mark in the x direction and see how many tick marks in the y direction. Okay, so again, a positive slope because we're rising left to right, and that looks like it's almost 2. So we'll say like 1.8 or something like that. So I'm going to give myself a positive 1.8 y coordinate, which is going to be kind of hard considering how cluttered I've made this. So at 5, come a 1.8, 1.75, something like that. All right, so let me clear the clutter off of this and we'll fill in and draw the derivative. All right, so another leap that we can make is because the function looks like a polynomial, then its derivative probably also is a polynomial. And so I'm just going to fill in, we see that wavy shape there. I'm going to fill in something that looks like a polynomial going through all those points that I plotted. All right, and when I'm checking your work, whenever you draw a graph like this, I am looking for, did you get those x-intercepts on the derivative in the right place? And do you have the y coordinates, the negative or the positive, approximately in the right spot? I'm not going to be too picky pulling out a ruler and making sure you've got exactly the right slope plotted. I just want you to have the idea of how we can get the derivative graph from the graph of the original function.